Good afternoon to one and all. It gives me immense pleasure to welcome you all to the 16th talk of TransPedia Research Talk Series organized by KSCSTE National Transportation Planning and Research Center NATPAC. This talk series is yet another unique venture of NATPAC designed to explore diverse topics from cutting-edge technologies to sustainable solutions. Here we'll feature researchers to share their valuable insights for kindling the spirit of future research and development in transportation. Today we have with us Dr. Vinayaraj V S, Research Scientist, Department of Civil Engineering, IIT Bombay, for sharing his valuable insights on the topic development of crash conflicts and assessment of safety performance functions for urban roundabouts in Indian context. Now, I request Dr. Shalini Yu, scientist, to deliver the welcome address.
Good afternoon, everyone. KSCSTE-NATPAC has initiated the TransPedia Talk Series, a technical discussion platform aimed at fostering research for mutual benefits by sharing knowledge on diverse topics ranging from cutting-edge technologies to sustainable solutions. This initiative aspires to create opportunities for young researchers worldwide to connect and collaborate, shaping the future of research and development in transportation. The inaugural session of the series was held on August 24, 2023 via an online platform with over 200 participants from prestigious institutions and organizations. The event began with an inaugural address by Professor Dr. Tom V. Matthew, Chairman of the Research Council, KSCSTE-NATPAC, and Professor at IIT Bombay. Over the past year and a half, around 15 sessions have been successfully conducted, covering a wide array of topics in transportation engineering. Today marks the 16th talk in the series presented by Dr. Vinayaraj V S, Research Scientist at Department of Civil Engineering, IIT Bombay. It's an honor and privilege to welcome our esteemed speaker who will share his expertise on analyzing crash conflicts and safety performance functions for Indian traffic scenarios. Following the presentation, there will be a question and answer session offering you the opportunity to engage directly with Dr. Vinayaraj. We encourage your active participation in this meaningful exchange of ideas. Thank you all once again for joining us. Please join me in extending a warm welcome to Dr. Vinayaraj V S as we look forward to his valuable insights. Thank you.
Thank you, ma'am, for your welcome note. Now, I would like to invite Dr. Vasudevan N, Junior Scientist, to introduce the speaker to the audience.
Good afternoon, all. Today we have Dr. Vinayaraj V S, Research Scientist in the Department of Civil Engineering, Indian Institute of Technology, Bombay. Dr. Vinayaraj received his doctorate from Transportation Systems Engineering, IIT Bombay, under the supervision of Professor P. Vedagiri in 2024. He has more than 6 years of experience at IIT Bombay in handling a wide range of sponsored research and industrial consultancy projects related to traffic flow management and road safety, such as Bloomberg Initiative for Global Road Safety, Johns Hopkins International Injury Research Unit, USA, National Highway Authority of India, Trill Urban Transport Private Limited, Pune, United Way of Mumbai, etc. He has been part of these projects in different capacities, including coordinating, monitoring, data collection, data analysis, documentation, and administrative related duties. He has received several fellowships from institutions such as ATPIO for TRB, USA, CITRS Asia Communications, USA, WCTR Advisory Award, Canada, IIT Bombay, and JASSO, indicating recognition of his work on permanent platforms. His research interests include road safety, traffic operations and management, and driver-pedestrian behavior modeling. He has 5 international journal publications, and his various papers were chosen for presentation at almost 18 international and national conferences. With this note, I welcome Dr. Vinayaraj to this talk series. Thank you.
Thank you, sir.
Thank you,
To deliver the talk.
Vinayaraj, good afternoon. Welcome.
Thank you, sir. Thank you. Yeah.
Okay. Go ahead with your presentation.
Yeah. Thank you for all. It was a very nice introduction about me, as well as like it's a very good opportunity for me to deliver this talk. I'll share my screen. Is it visible now? Hello.
Yes, it is.
Okay. I will start.
Can you keep in the slideshow?
Yeah. Good afternoon, all of you. Myself, Vinayaraj. I am working as a research scientist at IIT Bombay. Today, I am going to discuss about development of crash confit and assessment of safety performance function for urban roundabouts in Indian context. These are the outline of today's talk on introduction and what is the investigation approach for this reactive and proactive approach, and what's the framework, what is the data collection method, and what are the results of this safety, and finally concluding with the basic conclusion and contribution. As we know about the intersection has a significant role for ensuring safe and efficient operation of traffic in any transportation network. There are different type of intersection facilities. For our study, I chosen a roundabout because roundabout give an orderly continuous traffic flow which cause less delay or reduce the traffic conflict and collision severity. Second, as if you are looking for a highway safety manual or any standard like India HCM 2017 or IRC 65, it's a regular roundabout. But most of the roundabout studies are focused on the operational performance. It's like a delay analysis or gap accident mechanism, capacity estimation. But for our aim is to address the safety aspects and the intersection facilities. If you are looking to our more result or more statistics for last five years from 2013 to 2019, you can able to see that there is a gradual increase in the crashes happening at the roundabout facility. But generally, we are providing roundabout facility means to reduce the conflict and the crashes. But generally in Europe, 1997 they started Vision Zero strategies to reduce the crashes. Crashes means like zero fatalities and mine injuries. But we want to implement those things into our developing countries. In that case, for our study, I adopt 2-3 approaches. First one is like a reactive approach. It is purely based on the field, like crash data. From the crash data, we can come to know what is the causes of kind of accident or accident. But if you are waiting for the crashes occurring, but it is not that useful, because if you are, it is not unethical. It is for if you are thinking the humanitarian background, we have to wait for a long time. Then only we can suggest some of the remedial measures. In that case, we can move forward the priority approach. Then what are the statistical methods are chosen to address this kind of crashes or like conflict? Then I have chosen some of the investigation approach in my study. Some of them are explained over here. First one is reactive approach. In the reactive approach, I develop one of the safety performance measures and the crash modification factor to address the mitigation measures to reduce the crash at the roundabout. But it's a reactive approach. But we need to avoid such kind of crashes and identify the possible conflict before occurring the crashes. In that case, we can move forward with the priority approach. But if you wanted to analyze such kind of conflict from the field, we doesn't have any separate tool to extract the data or trajectory data. In that case, we developed our own tool called Drishti that is based on the UV approach. In this approach, we can extract the trajectory, then we can identify what is a possible traffic conflict happening at any of the facilities. I will explain some of the framework over here. For first thing, I will explain about the reactive approach. I already collected around 20 roundabout location crash data from different police station report, from the FIR based report, as well as some of the data collected from the State Crime Record of Bureau in Trivandrum city. Most of the case studies I considered in Kerala state itself. I collected around 1,450 crash data from this 20 roundabout. Then for the geometric analysis, I use data station as well as DGPS equipment to extract the exact geometry parameters from the field. Then basic parameters, traffic flow parameters extract from the video editor software as well as the VGG and CVAT annotator tool. Then identify the, then plotted the descriptive statistics of the whole geometric traffic and environmental characteristics of the corresponding facilities. Some of the pictorial representation of my data collection experience I'm showing over here. Once you collect the crash data, I just extracted compare the existing type of conflict. What are the conflict generally occur at the roundabout vicinity? Then I found that rear end and angle collisions are mostly occurring at the roundabout facilities. That leads to majority of crashes lead to major injury, and fatal injuries are compared to fatal injuries are very less. That will be a good thing. Then first of all, then I will move for the development of a safety performance function. The safety performance function is nothing but it is estimating the number of crashes occurring at a particular facilities. That is called the safety performance function. There are a lot of methods are there to explain the safety performance function. Example, Poisson methods and negative binomial, zero inflated negative binomial model. There are different lot of mathematical models are available. But based on the crash data, we can identify what type of method we can use for developing the safety performance function. For in my study, what I did some of the statistical tests. Then mean, if your variance is greater than mean, then it's an over dispersion. We can use for negative binomial. If it is our mean and variance are equal, then we can go for the regression. Like that, we can check with the different statistical method. Accordingly, we can choose one of the method to develop in the safety performance function. In this case, this is one of the mathematical expression. Y is equal to exponential of beta 0 plus b1 x1 plus standard error. Y is equal to expected number of crashes at roundabout vicinity, and xi is the explanatory variable of roundabout vicinity. Then beta 0 is a intercept and other model coefficient. From once you collect the crash data, first we can analyze what are the parameters are there in the crash data. In generally, most of the cases crash data are in different station. Like if it is looking into Kerala, if it is looking into Mumbai, the entering data are in different way. For our research purpose, we need to refer at least the FIR report. Some of the parameters we can take it from that. Accordingly, I just collected data from the police station as well as looking into the FIR report. Then find out then identify what are the crash parameters, like what type of at what time its crash occurs and what are the vehicles involved, whether it is rear end side step or angle collision, which location that is day and night condition, weekday or weekend. Then other aspect I considered for developing the safety performance function, this geometry parameter of the corresponding that facilities, because the crashes happen lot of numerous reasons are there, like due to either due to the driver behavior, that is another aspect. Then due to the road facilities, any issues like or environmental factors. I considered all the factors. Then what I did, I considered roundabout into 4 approaches, like major and minor approaches. In that case, for in detail understanding of the safety aspect at roundabout, I just split the roundabout into 4 aspects, like entering approach and within the circulator line and exit approaching level and the whole roundabout. If you are considering roundabout as a whole, we can consider minimum number of parameters. That won't tell us the exact reason for occurring of crash at roundabout. In that case, I split it into this exit, entry, and circulator level. Then we develop a safety performance measure for roundabout. Then another aspect is like, but most of the cases we doesn't have any before after crash data. In that case, like we need to consider about the cross-sectional approaches method. In this method, this method tell us if you give any improvement measures, how it's effectively working in the field. That is one of the equation, like CMFI is e raised to b into xi minus x1 base. Here, the CMF of corresponding factor is equal to, that is a base factor. CMF S base means if you are considering the geometry parameter, suppose rounded central and diameter, that is the base of that one. We can identify from the IRC code what is the base if you are considering a roundabout. From that, we can identify the estimated number of crashes before and after that. From here, we can see that I use the crash modification factor and plot the graph. If a circulating roadway width increases, the occurrence of crash decreases. If it is suppose we are considering, let's say, the circulating roadway width, nothing but it is like a vehicle traversing a particular path only. That is called a circulating roadway width. If it is like width is less, then vehicles are moved very closely. There is higher chance of occurring sides of conflict. Then other thing is maneuvering. It's very difficult for a roundabout facility. In that case, we need like circulating width is little bit increases. Then there is occurrence of crashes at roundabout is less. Then another parameter, weaving length and weaving width. This weaving length and weaving width mainly depend on like the safety aspect as well as the capacity determination. If your weaving length increases, the occurrence of crashes decrease at roundabout. We cannot extend for separate beyond the particular limit. If your weaving length means the most of the vehicles diverging and as well as merging happening at this particular portion only weaving length. Then weaving width, if a weaving width increases, the occurrence of crashes also increases. This is especially for the single lane roundabout. Then another aspect I found from the roundabout, the two-wheeler, the percentage of two-wheeler is very high because two-wheeler is very smaller in size, but two-wheeler can do the higher maneuverability power as well as a filtering behavior. Because of this reason, there is a higher chance of occurring at a crashes at a roundabout vicinity because of the two-wheeler. Then entry angle. Entry angle is a proxy of geometry design of roundabout. The entry angle increases vehicle also increases speed at the roundabout vicinity. It also leads to crashes at the vicinity of roundabout. As per the standard, IRC is saying that we can keep the roundabout entry angle between 20 to 60 degree. If you are providing that, we can reduce the crashes at the roundabout vicinity. But most of the time, we don't know what is the reason because most of the time the error how it's occurring either due to the implementation before installing in roundabout, we have to thoroughly cross-check the design whether it is designed as per the standard or not. Then we can try to rectify if any error is there. We can try to rectify. Accordingly, we can reduce the crashes and we can make it a safe. Then another aspect I done in the area of severity. First, we did safety performance function. It is nothing but it's identifying the expected number of crashes. But it cannot explain other driver behavior parameter from that aspect. In that case, compared with the safety performance function, the severity is more informative than the SPF. In this case, we have there a lot of mathematical models are there. Like ordered probit model, we can use mixed logic. Like a lot of models are available because our crash data is it's an ordering nature from minor, major, serious, and death. Because of this order nature of crash data, we can use the ordered probit model. It is also an ordering nature. Then from that we can identify that what are the different contributing factors leads to the higher severity. That aspect we can get from this kind of modeling technique. For this case, I considered a total 1,450 sample size. After some outliers are there that we removed, then around 1,400 data sample is for the modeling technique. 75% of data we used for the modeling and remaining 25% used for the validation purpose. Here I use negative logic software to develop such model. Once the model developed, the explanation based on the marginal effect. The marginal effect will tell us you the direction and the magnitude of that variable. Then you can easily understand what is the effect of this variable leads to the severity. These are the outcome got obtained from our study. The circulation width and our daily traffic, the percentage two-wheeler process speed limit are the most of the influencing factor at the roundabout vicinity. Then the crash, most of the studies, roundabout study, they are focusing on the roundabout itself. They are not segregating the roundabout in different approaches because the crashes are not occurring at any particular point. It can either go to the entry level or exit level or inside the circulator level. That is means the asymmetric effect of geometry also comes in picture. The results of this study are published in different various journals. If you want to need more talk about this thing, you can refer some of the journal. I already published in TRR and other journals. Next step is the development of tool. Here, IIT have one of development tool called Drishti. It is called a zone integrator system for heterogeneous traffic system. This name is suggested by Dr. Vasudevan when he was here as a postdoctoral fellow. Because in this case, why we are developing this software? Because a lot of softwares are there. IIT Bombay Extractor is there. Some paid software like data from the sky. A lot of softwares are there because that is for the commercial purpose. We need to pay them, then only we can use this software because our aim is to distribute to different institute, like for the academics institute for there, because a lot of students are struggling with extracting the trajectory data from the different facilities by using because of unavailable tool. For developing this tool, what we did, we collected a lot of drone-based data from the different road facilities, not from the roundabout. Roundabout is there, signalized intersection, unsignalized intersection, mid-block. Then we annotated data. Annotation means nothing but cropping the images of vehicle from the image. Like that, we collected around 8.5 million data annotated image of different road facilities. For annotation purpose, we use CVAT tool as well as VGG annotation tool. Once we annotated, then we created one data set called dataset formation. Once we dataset formatted, we have a lot of machine learning or deep learning architectures are there. Then we can do the transfer learning technique. We can fine tune our architecture along with this annotated image. Then we can come up with a new detection model. Before developing this detection model, suppose we have, let's say we have 100% of sample. Among 100% of sample, 70% of samples are used for the training, and then remaining 20% for the validation and 10% for testing. Like that, we can segregate. Then we did a lot of transfer learning and fine tuning. We found one detection model and tracking algorithm. That algorithm, we can pass it to any of the collected video from the drone-based thing. This is a software interface. Once you collect the data, you can upload the video data into software. Then if you want, what are the parameters you required? That parameters we can extract from the software. We tried all the facilities like roundabout, mid-block, as well as intersection. That is a sample we can see from over here. Then we tried a different architectures. YOLO, different families are there now. YOLO 11s are running. At that time we tried YOLO V5. That we got a better result as compared to the other architecture, single shot detector, fast RCN, return, etc. Then once you develop this architecture, then the detection model, then we look for the performance of detection model. There are different methods are there to identify the performance of model. First one is recall, then followed by precision MAP F1 score. This will tell you the accuracy or the precision of this developed model. From that, we identified the YOLO V5 medium architecture is giving the better results. This is one of the pictorial representation of tracking of YOLO V5. This is a perform precision rate of each vehicle category. From here, we can see that we can get more than 90% accuracy for the car, three-wheeler and heavy vehicle. But two-wheeler and LCV are less accuracy, but it is more than 80% at that time. Now we find out we got more accuracy as well. Then how once you done this thing, how you validate this vehicle detection? This is called confusion matrix. In confusion matrix, suppose we develop, we pass our video to the software. Let's say here, if you look into here, you can see that the interior motorized two-wheeler, three-wheeler car, LCV, heavy vehicle. Here we can see that we have 108 instances. Total, we have 108 detection. 108 total vehicle. That vehicle detect only 102. That is a detection we got it from the software. Then from 108, how many vehicle detected as two-wheeler? 101 vehicle detected as a two-wheeler, 1 vehicle detected as a three-wheeler, 6 vehicle are undetected. This is the way we find out the overall accuracy of the tool. This for roundabout. Then we tried for, similarly we tried for the signal intersection. Similarly we tried for the mid block as well. Then next what we did, that at the same time the drone is flying, we kept the V-box equipment in the tested vehicle. Then drone is capturing the vehicle at the ground. Then the V-box also capturing the vehicle coordinates while traveling this particular tested track. Then we validated with the V-box and the drone data. Here we did 3-4 trials at the different facilities. We did roundabout as well as a mid block. The T1, T2, T3 indicate in the trial 1, trial 2, trial 3. Then we made a one test track in the real field. Then drone was above. Then the test vehicle was moving the track. Then we extracted the speed of that track of the corresponding mid block and the roundabout. Then we find out what is the speed of manual extraction with the help of our tool as well as the V-box. Then we found out the error is 2.17. It means our results are more accurate. This is one of the examples of the trajectory data extracted from our tool. Next step is crash risk modeling. Crash risk modeling means what I explained before that, the reality approach, I already mentioned here. The reality approach, we have to wait for the crash data, then only we can implement some of the measures, but that is not ethical one. In that case, real-time field also, we can use some of the surrogate approach. Here, surrogate approach is the surrogate approach tells you the different type of conflict, like the nearness of crashes, the crash generation process. But most of the studies, the crash generation process are not available. That in that case, we need a detailed trajectory data. In that case, we developed the software, then we extracted the trajectory from that software. This is from here we can say there are 3 phases: pre-crash phase, in-crash, and post-crash phase. Suppose we are driving, then we identify that some of the vehicles are like suddenly lane changing. That is one of the trigger. Then the driver understood that it's a critical event. If the driver has to take evasive action to avoid such kind of crash occurrence, then there is no crash. We can avoid the crash. If it is not there, it leads to a crash. Once the crash happens, we'll go for the post-crash phase, like hospital case. For this, there are a lot of surrogate safety approaches there. Methods, time to collision and post-encroachment time, DAR, PSD, a lot of methods are there. For here, our new methods are there. Anticipated collision time. It is similar to the time to collision, but it is the function. It is a little bit different. What this method will tell is the shortest distance between the vehicle, the shorter distance between the vehicle, and the rate of approach along with the shorter distance. For most of the, if you are looking into time to collision, they are only considering the speed difference. For the ISCT, one advantage is there, it will capture the driver behavior parameter as well as it will speed, we are considering the acceleration as well as the yaw rate of the vehicle also. From that, we can identify that the exact position of the vehicle and what type of conflict. This trajectory will tell us you the crash generation process from that. This method is introduced by Suvin and Dr. Mallikarjunan Sinju from IIT Guwahati. Once we collect the trajectory data, there are a lot of noises are there. To avoid such kind of noises, they introduce one of the smoothing technique called recursive ensemble low pass filter. It is adaptive smoothing technique. Based on the error, it will be not over smooth, not under smooth. Here we can see that the red color is the spikes are the noises, but it is smoothing. You can see the other color like this red and this black color. For our study, we extracted around 40,000 trajectory data from different roundabout facilities by using our tool. Then when we pass to the anticipated collision algorithm to that trajectory, then identified what are the possible conflicts. Then from here we can see that two-wheelers and car were more involved in the angle collision followed by side swap conflict. But before considering this one, we can fix some of the threshold. Tentatively, we considered some of the threshold from the recent literature. From here, in ACT has two small part like two indicator like anticipated collision, time exposed, and time integrated anticipated collision. From here, you can see that the ACT, the path will tell you what is the exposure time of that vehicle with another vehicle. What is the severity, potential severity of that collision of that vehicle also tell. It is nothing but you can see that suppose we are assuming some of the threshold values. So let's say we assume threshold is 2, that is ACT star. The below that threshold, these vehicles are unsafe. That sum of all the time will tell you the time exposure time of that vehicle. The area of this portion will tell you the severity of potential collision. For our study, we considered two-wheeler, we consider all the vehicle category. Then we find out that passenger car is more involved in the exposure as well as the higher severity as compared to the two-wheeler. Because these two cars are more involved in that phase, but two-wheeler has less size and higher maneuverability, higher filtering behavior. That's why their exposure is less and severity is also less. But two-wheeler will make more accident with a different kind of vehicles. Then we check the statistical test also. Is there any significant difference between this severity and the exposure? Then we found that there is a severity. There is a statistical difference between exposure as well as severity. Then we move forward the crash risk modeling based on the conflict. We consider the advanced technical model extreme value theory, because extreme value theory is nothing but it is a probabilistic modeling technique. It estimating the crashes from the traffic conflict. Because in field, crashes are the rare event, but conflict are occurring a lot. But in the real field, by our naked eye, we cannot identify the conflict. In that case, we need some of the video-based data. Then only we can analyze the traffic conflict. It is mostly happening because, let's say, suppose per year on location crash happening, 1 or 2 crashes happening. But in reality, the lot of conflicts are happening. But if you are using this method, there are a lot of approaches are there. Here we are considering block maxima as well as the peak over threshold method. In block maxima, the distribution is generalized extreme value distribution. In peak over threshold, also generalized priority distribution method. Here in block maxima, we consider the block. Suppose we wanted to analyze the 1 hour data, we can consider every 50 minutes block. Then we can analyze the crash risk. In peak over threshold, Pico threshold approach, that is some trade-off between the variance and biases. In that case, we can consider PIT approach. This is the generalized parent distribution equation between the extreme value theory method for developing the crashes. For our study, we develop conflict risk modeling for different type of conflict, the angle, rear end, and side star. Then we found that there is a speed difference, center line diameter, a number of circular lines, circulating width are the most influencing covariates, mostly involving the crashes or conflict occurring at the roundabout facility. As well as there is, we found some of the threshold value. Because like there is in mixed traffic condition aspiration roundabout, there is no clear-cut threshold limit of identifying such case. We found out 0.5 to 2 seconds. That variation we got. This paper also published in the TRB. Here I will explain you how to consider, how to develop, how to find out the threshold. There are two methods are there, MLR method as well as a stability plot method. We use the stability plot method. In the stability plot method, will give the threshold level of each vehicle category. That here from here we can see that the threshold value is between 1 to 0. Here our threshold value we will take 1. Then once you develop this model, first you develop a threshold value, then we can add covariates, because first you develop the stationary model. In this stationary model, only the constant will be there. Then, but in reality, a lot of heterogeneities are there, like road geometry variation is there, vehicles are moving different timing, vehicle flows, everything is different. In that case, we move for the non-stationary modeling. In non-stationary modeling, will tell us what are the factors mostly influencing for occurring the conflict at the particular roundabout facility. Once you find out the threshold and the crash probability, we can estimate the annual crashes occurring at a particular roundabout facility based on the crashes modeling. For my study, some of the contributions we can use safety performance function we develop, can identify the hotspot, what are the risk component and expected number of crashes at a roundabout facility. The tool we can use for the extend the trajectory from different road facility. Then the anticipated time collision, anticipated collision time, that method applicability we tried in the roundabout facility, it is working very well. And also we developed the crashes model that for identifying the accident prone location before occurring any crash. This thing we can implement for the real-time threat assessment also. Then we developed, we found some of the threshold range. This threshold range we can use for different type of vehicle category for designing a collision warning system, especially in the heterogeneous traffic condition in CAVs. Some of the reference I am showing here. Thank you. Hello.
Thank you, sir.
Yeah.
Vinayaraj, this is Shahid. Can you hear me?
Yeah, I can hear, sir. Yeah.
Sir, you are consider, did you consider the pedestrians in your model?
Pedestrian in crash data we consider as a vulnerable road user for the crash data case.
So you didn't
Because
collect
we
any
consider
pedestrian accidents in your study?
Yeah,
regarding the roundabout?
Yeah, roundabout I consider pedestrian accident that I model consider as a vulnerable road user, pedestrian, bicycle and the two-wheeler considered together. But in the conflict analysis, I did not even consider the pedestrian.
You consider the severity, right, for the modeling?
Yes, yes.
Yeah, well, how you get the severity, different class of severity or something like this from the accident data, or you collected from the hospital or what?
No, I did not go for any hospital. In a crash data, they are mentioning that is, suppose if let's say we are considering one of the crashes, they mention whether it is a major injury, minor injury, or fatal. That order only I considered like.
If there is
severity.
no injury is if there is no injury caused, then how will you do that thing?
In the crash data, some cases there
There's
is no injury.
vehicle to vehicle damage is there. Only vehicle to vehicle damage is there. How you consider?
Yeah, vehicle to vehicle damage I consider as a zero injury. There is no injury. That I coded as zero. One means minor injury. Two
That
means
is a crash,
major
right?
injury.
It is a crash, but
that is
you are not considered as an fatal injury cause, right?
that is injury crash for the from the crash data. On the conflict, I did not consider any pedestrian other aspects.
Yeah, you have that developed some software or something like for detecting the vehicle. So did you get the bus and all in this identification detection?
Yeah, bus will get only issue there. Pedestrian won't detect. All
Because
vehicle can detect.
you show some table which not showing you bus details or something like that. Only some vehicle.
Vehicle in the sense two-wheeler, three-wheeler. I just mentioned the name. Motorist, two-wheeler, three-wheeler, car, then LCV, then heavy vehicle. Heavy vehicle considered bus and truck together.
Okay, you can get separate, right? Bus and
Yeah,
vehicle separate.
Yeah, yes. But pedestrian is one of the limitation of the software.
Okay. Then how about the performance during the night time?
Nighttime also it is one of the limitation. After 7:30 it won't detect. We need to use thermal camera, then we need that recording. Otherwise, normally it won't work. Only for the daytime it will work. Lighting conditions.
Usually, what happened to drone, using drone, you cannot do drone data collection for long hours. Like if it is more than 30 minutes, we have to replace the drone, right?
Yeah, every 25 minutes we have to replace the drone.
There is any solution for that?
Generally, here what we used to do, we have 2 to 3 drones. We have once the battery, we can get indication battery about to over. Then we can fly another drone. We can fly and up to the same position. Then we can down the first drone. Like that only we are trying to collect the data from accordingly.
You have mentioned some exploratory variables for safety performance function, something. What are the exploratory factors that you used?
For the safety performance function for the time of occurrence, I considered then what type of collision, then it's a weekday or weekend, then as well as geometric parameters, the whether a roundabout is single line or like any other like geometry width, center line diameter, that parameter considered.
Okay,
All
thank you.
external traffic.
Yeah. It was a nice presentation. Thanks.
Thank you.
Hello.
Yeah.
Hello. First of all, it was a nice presentation. I have few doubts regarding the data collection part. You have already told that about 20 locations you have collected the data. So I have a doubt that how much duration for each location have you collected the data, or how many days during the peak hours or off peak hours to capture the conflicts?
Yeah, for 20 location for the crash data, 20 roundabout, but the conflict analysis I considered only 6 to 7 location. Each location morning peak hour, evening peak hour, and one off peak hour. Total 3 hours we collected. Some of the location in Kerala we collected 3 hours, but in other Maharashtra location due to the permission issue, we consider only 1 hour, only peak hour.
Okay. Up to what height did the drone was used for capturing the aerial view?
If it is roundabout diameter is very big, then we fly it up to 120, 130 meter height.
It was a still view or a moving one?
No, it was still view only. Drone is
Okay.
like stationary all day.
Okay. Thank you.
Yeah. Any other question? Any other suggestion, sir?
I have a doubt.
Hello, sir. I have to.
Arun sir, you can continue, sir.
Hello, Vinayaraj, have you considered the roundabout with the signal?
No. It's unsuccessful roundabout only.
Then you mentioned about the number of lanes in the roundabout. That is also one of the factors in the last slide. In the slides that you shown towards the end, no, it was shown like that number of revolving lanes or something.
Number of circulating lines.
Yeah, number of circulating lanes.
Yeah.
So
If it
you
is
have
if it is a carriage width is more than 7, generally we consider path is 3.5 meter, 3 to 3.5 meter. If it is 7, then we can consider 2 circulating line. 2 vehicles are at a time circulating.
Is it theoretically possible?
If you are looking into like cash house or a roundabout, at that time 2 vehicles are circulating, right? Theoretically. Hello.
Okay.
Yeah, because it is a carriage width is like it is more than 7 or 8 meter. At a time 2 vehicles are circulating over there around. In most of the places, like it is Vellambalam also similarly only. Anyway, there is no single roundabout with one vehicle revolving there.
Okay.
Yeah, Vinayaraj, actually, I have a couple of questions. You have mentioned that you have used YOLO as your architectural framework, and you have mentioned 2 other separate framework as well. So, did you compare these 3 among each other, or you have just selected YOLO as the best one?
No. Actually, initially we tried a lot of architectures are there. YOLO a lot of family. Now YOLO we have 11 is there. We tried initially RetinaNet, then a single shot indicator, faster RC. We tried a lot of architecture, but among that, like we got a higher accuracy and higher result in YOLO only. That comparison we all
what
did.
parameter have you checked for finding out the accuracy? Only statistical analysis or this trajectory variation?
No. Like first that architecture like detection accuracy. How many vehicles are detecting properly? That we consider for the confusion matrix.
Okay.
Then I validated. Somebody asked, Ardhar asked validation. In validation also, like in manually in that case, what we did, we have that video data manually. We count the total vehicle. We plot in that we have option the software. We can make some gate over each approach. Then we can find out how many vehicles are passing through the particular gate. The software will automatically give the total number of vehicle count based on the different class of vehicle. Then manually also we can check how many vehicles are passing the particular gate. Through that also we validated.
In the site itself, or it is conducted separately?
Separately, we have conducted different. During data collection, also from the video, we can manually count how many vehicles are passing. If you are draw a line at any of the approach. Similarly, the software also we can draw a line at the same approach. Then how many vehicles are passing that approach? They automatically identify how many vehicles are passing that approach. That is in classified vehicle count. From that also we validate.
Okay, and the second question is, you have mentioned about this ACT concept, and there is 2 concepts called exposure and severity, right? Severity times,
Yes,
I think. So I think the 2-wheelers are the exposure for 2-wheelers are higher, but it is getting crash. I mean, chances for getting crashes is lower than compared to car.
The exposure is exposure rate of car is higher. Because like if any of the cars are turning to the roundabout, the car has to spend more time over there. Understood, na?
But exposure
That
is
is
exposure to crash or
exposure to crash, exposure time. But two-wheeler issue there, the total exposure is very less because the two-wheeler has very high filtering and high maneuverability power. They can percolate to in between the car or like any vehicle. It can easily negotiate the roundabout and move exit the roundabout also. That's the
But then
overall
that
time is less.
exposure is higher also, right? That exposure, then
For
also it is kind of exposure only.
that is also exposure, but in two-wheeler case, the vehicles are moving high speed, then exposure will be very less. But chance of accidents are higher if you are thinking in another perspective.
Okay.
Suppose you are traveling, suppose you are driving on the car in the roundabout, along with your colleagues are following you in bike. But ahead of you, like some other truck or something is there, you are facing some exposure with the nearness of crash with the truck. Because truck need a higher entry angle to perpetrate the roundabout. But two-wheeler as there is it is small in size, but it is like high maneuverability and high filtering here. He can move very fast and exit the roundabout. That is a getting time is less.
Okay. Yeah, thank you.
This is Samson.
Hello, sir.
Yeah. Okay. This is only a general question. Okay. It was a nice presentation. Good. That listener did a good work, and you shared that one with our people. My general question is like this. You are talking about the roundabout. Am I right?
Yes, sir.
Like how in India, like in general, I found that one the concept of roundabout or introduction of the roundabout is coming down like anything. Many cities they are moving it or they are making that one as a mini roundabout or some form of roundabout. But in European countries and other countries, it is used as an effective treatment to reduce the speed.
Yeah, yes, sir. Yeah, in some of the countries, they are using turbo roundabout. Once it's entered into that roundabout, the speed will automatically reduce according to their design. But the same concept we can introduce here, but we need more land to install this roundabout, that construct that roundabout. But in Indian situation, our situation is it's a kind of heterogeneity, mixed traffic. Most of the two-wheelers are creating filtering and maneuverability. That's why get a lot of accident roundabout. But once the roundabout diameter is very high, then we may not work over here. We can say that we can reduce the roundabout diameter in particular such a way that we can reduce the crashes at roundabout facilities.
Okay, this is one observation. Even some forums also we have seen that one. Shahim, please switch mute your audio. Shahim.
Hello, sir. Yeah.
Okay, so this is one observation. Fine. Anyway, thank you for the observation. Good luck.
Thank you, sir. Thank you for giving this opportunity to me for deliver this talk, sir.
We need your support, no? Okay. Now, probably think of lesson of what collaboration we can have to extend your research probably to Kerala or with the NATPAC. What best you can do? Just think.
Yes, sir. Okay.
Vasu is with you. Vasu
Yes.
can help. Yes, that can be a good route through which you can collaborate and maybe something we can implement from your research outcomes. Okay.
Okay, sir. Thank you, sir. Thank you for the good words.
That is all. That's all from my side.
Yeah, Dr. Vasu.
Yeah, Vinny, there are two more questions in the chat box. First question is, can you please explain the part where you use the B box?
Yeah, VBooks are used for the speed validation. What I did, by collecting the video data, we have test vehicle. In that test vehicle, we kept a VBox over there. At the same time, we marked 2 point, let's say point A and B. Then the test vehicle is passing. Then the drone already capturing that vehicles, right? Then once the test track over, then we can extract the parameters from the VBox data, as well as like in manually we know point A to point B, what's the speed, like we know the distance, then we can find the speed. Then VBox will also give the speed of that average speed. Then as well as then our software will also give our speed. Then we can compare and validate it. This way I used VBox over there.
Yeah, okay. And the second question is, what is the range of diameter of the roundabout considered for your study?
Roundabout, I consider diameter from central and describable diameter from 20 to 70.
Okay.
That is
and,
as per the IRC standard.
Then another question is, how do you come across 1 hour data to crashes or 1 year?
1 year, yeah. That we have one extreme value theory on projecting equations are there. From 1 hour I converted into 24 hours. From that I converted to 365 days. Then one mathematical equations are available. Through that I will calculated the crashes for 1 year.
You have extrapolated the data, correct?
Not extrapolate the data. That equation is there. Crashes equation
Projecting,
is there.
projecting to 1 year, right? Okay.
1 year, yeah.
Yeah, another question is, you have given expected count as 3. Have you checked with the real-time data after that?
Yeah, I validated with the real-time data, but we can't rely on our real-time crash data because like I cannot take the real-time data. I just I consider this roundabout in 2021. Then I consider that some of the month data, crash data from the Kerala, but at that time I validated with the actual crash data and whatever from the extreme value theory model, giving the crash risk that data that values, but it is like under dispersed only. Around 70% is almost magic. Some under dispersion is there, but we need a more like accurate data for more places. Then only we can come up with some kind of relationship with the actual crash data with the conflict. Our team, some of the researchers are doing that aspect over here.
Then the expected count is number crashes or fatalities. I mean, number of crashes or fatalities.
Number of crashes, total crashes.
Okay.
Thank you.
So Ashwati, over to you.
Thank you, sir. I request Srishjit PP, Junior Scientist, to propose the vote of thanks.
Good afternoon, all. On behalf of KSCSTE-NATPAC, I would like to express my sincere gratitude to each one of you for joining the 16th TransPedia research talk on the topic, Development of Crash Conflicts and Assessment of Safety Performance Function for Urban Roundabouts in Indian Context. It has been an exciting and outstanding session. First and foremost, I would like to express my deepest appreciation to our distinguished speaker, Dr. Vinayaraj V S, for sharing his valuable research finding with us. Today's session has shed a light on the critical aspect of improving safety at urban roundabouts. And let us use these findings as a foundation to address the traffic challenges and work collaboratively towards safe and more efficient urban transportation system. Once again, thank you, Dr. Vinayaraj, for delivering such a wonderful presentation. And I want to express my sincere thanks to all the attendees for your participations and interactions. And we believe that our TransPedia Research Talk series is getting beneficial to students, academics, and working professionals, etc. Furthermore, a big thanks to our director, division heads, and TransPedia coordinating team for making this event possible. Your support has made it possible for us to come together and explore this important topic. We encourage all the participants to join the upcoming online series organized by KSCSTE-NATPAC. Thank you. Thank you all.
Thank you.
Thank you.